For 1,000 years, Earth anchored the universe at its center. Then in 1543, Nicholas Copernicus published a radical challenge: the Sun, not Earth, held that place. The heliocentric revolution had begun, though acceptance would require another century of struggle. Copernicus challenged Ptolemy not through superior observations, but aesthetic reasoning. The heliocentric system proved simpler and more elegant. Circular orbits around the Sun eliminated epicycles entirely. He believed beauty revealed truth. His conclusion proved correct, though his circular orbits were fundamentally wrong. Copernicus, a Catholic Church canon, delayed publication for decades from fear of ridicule. He dedicated the Revolutionibus to Pope Paul III himself. The Church remained silent until 1616, 73 years later, only after Galileo transformed it into theological controversy. Copernicus receives the first printed copy of De Revolutionibus on his deathbed, May 24, 1543. Whether fact or legend, the timing reveals a cautious man who spent decades observing the heavens before finally sharing his revolutionary discovery with the world. Johannes Kepler solved what Copernicus could not. Armed with Tycho Brahe's precise observations of Mars, he discovered that planets orbit the Sun not in circles, but in ellipses. This elegant truth revealed the actual architecture of the solar system. Kepler's 3 laws of planetary motion, published from 1609 to 1619, reveal how planets orbit in ellipses with the Sun at one focus, sweeping equal areas in equal times. Yet these elegant mathematical truths lack physical explanation. Newton would provide that 60 years later. In 1609, Galileo learns of a Dutch invention magnifying distant objects. He builds his own, improving it dramatically. But Galileo's genius lies in pointing it skyward. His winter observations shatter the Ptolemaic universe forever. Jupiter's 4 moons orbit not Earth, but Jupiter itself. Venus displays lunar phases, orbiting the Sun. Galileo's telescope reveals a cratered, imperfect moon. His 1610 findings in Sidereus Nuncius spread rapidly across Europe, forcing astronomers to reconsider the cosmos entirely. Galileo's 1633 trial transcends astronomy. The Inquisition challenges who interprets nature's laws. Though warned in 1616 against defending heliocentrism, his 1632 dialogue championed Copernicus, enraging Pope Urban VIII. Science, personality, and politics collide in judgment. Galileo recanted under threat, confined to house arrest for life. The legend of his whispered defiance, "Yet it moves," remains unproven. Yet it captures profound truth: no recantation could alter reality. The Inquisition silenced the man, but not the planet's motion. Isaac Newton, born the year Galileo died, inherited their questions. Reading Kepler and Galileo, he asked why ellipses, why acceleration? At Woolsthorpe during plague years, Newton glimpsed the answer. One force, operating across all scales, connected the falling apple to the moon. In 1543, placing the Sun at the center required extraordinary courage. Earth, stripped of its privileged position, became merely one planet among many orbiting an ordinary star. Astronomy would spend centuries confirming this humbling truth. Copernicus delays publication. Kepler discovers elliptical orbits in Tycho's data. Galileo glimpses Jupiter's moons through his telescope. The Inquisition resists. Newton unifies all with gravity. 1 century transforms humanity's understanding of its place in the cosmos. I am Takku. The moment Copernicus proved we are not the center, everything in science became possible. Subscribe to Wisdom of Takku, because humility is the foundation of all true discovery.